So this is our last section in this chapter. Remember, I kind of mentioned to you already, but I'm thinking that we might take our test next Thursday before Easter break. No school Friday. So this will wrap up, and so that will leave us with next week just doing review stuff all week and then test on Thursday. Okay? So we are just in this section, not necessarily doing anything new, but talking about some situations where logarithms actually come into play, why they're useful, where they show up. One option is with calculating pH. So in your science classes, pH is actually a mathematical calculation. It's found by doing the negative log of H3O+. H3O+ is a hydronium ion concentration. You wouldn't have to memorize these formulas. Anything that I'm giving you today, I would give you that formula. We just have to be able to plug things in and solve for whichever variable needed. So if I look at an example, if I asked you to find the pH of a solution with H3O+ equal to 2.5 times 10 to the negative 4. So at the top of your notes handout, I put all the formulas that we're going to be using, so we're actually jumping down to example 1 right now. So pH, looking in that first box on the top, it says pH is a negative log of H3O+. And my H3O+ is 2.5 times 10 to the negative 4 power. So all you're doing is plugging that into your calculator. I want everybody to do it so we can make sure we're getting the right answer. So, negative.
What parentheses suffice?
Yes.
3.6021.
And pH, we typically just go to 1 decimal place. So your pH is 3.6. No, pH is.
Wait, what did I do wrong?
2 minutes. All right. Did everyone get that answer?
Yes.
All right. So second thing, find the hydronium ion concentration of a solution with a pH of 7.1. So we're using the same formula as the pH. So my pH is 7.1 equals negative log H3O+. All right, so this is solving an equation with my logs. So let's start. What should we do with the negative?
Bring it to the top.
Divide.
Yeah, we could either take it up and make a negative 1 exponent or just divide by negative 1. I think dividing might be easier. Negative 1 equals log H3O+. Okay. There's a log on one side. You just get done solving all these equations. Change it to exponential. What's the base of this log? 10 to the negative 7.1 equals H3O+. And so we get 10 to the negative 7.1 power. Notice, these look weird. You have a really long decimal at the end. It says like e to the negative 8. Keep in mind this first one, when it gave us scientific notation like this. So we would say 7.9 times e to the negative 8 just means 10 to the negative 8 power. So that's our hydronium ion concentration.
When you say like that, makes it kind of more confusing.
When I say the word,
I'm pretty sure I slept through part of the 0.5.
Don't do
We
physics.
still have to.
Might have been the math.
Don't do chemistry.
It's really confusing. I don't.
I think you can solve an equation. Are there any questions? Did everybody get this when they put it in their calculator?
Actually, yeah, no, I do have a question. How do you get 7.9?
Okay.
Wait, is that extra?
You type in
At times 10 to the negative.
Throw it into 10. I think that's what you call it. Let me see what you put. No, I just want to.
Alright,
Yours just says the new size of the notation.
next calculator problem. Another thing that we encounter with this, exponential growth and decay. Alright, the formula for exponential growth and decay. A of t, the amount you have at a given point in time, is equal to a sub 0, that's your beginning amount, e to the kt power. So this is our formula. A of t, so that's the amount at time t, equals a sub 0, so that's beginning amount.
Just prototype.
E is a number on our calculator, k is a constant.
Well, I say K constant, but constancy. Ooh, I'm picking your brain.
You could use whatever letters you
Wait,
want.
did it say amount of time or amount?
Amount at time t.
Okay, and the second A means beginning
That's the
amount.
beginning amount. And k is a constant.
Then K is a constant.
When k is greater than 0, that will mean you have growth. The amount you have is increasing. When k is less than 0, that would be decay. The amount you have is getting smaller over time.
I told you it's the
Don't we do this in
storm.
physical science?
The wind
That's
slides.
real calm.
So, let's look at an example. If 800 grams of a radioactive substance are present initially, so the initial, my beginning amount is 800. And 2.5 years later, only 400 grams remain.
That's AT, right?
Mhm, so
A sub 0?
the a sub 0 is 800.
A sub D.
So after 2.5 years, we only have 400. The question is, how much will we have after 4 years?
I feel like that's their problem, not mine.
So,
Especially, yeah.
if we look at this, when
After 4 more years or after?
4 years total, so a total of 4 years time.
So
What, I'm so confused. It's K sub what?
All right, just let me talk for a minute, guys. If you are looking at this equation, the a of t and the t are going to change. Okay, the time continues to pass, the amount we have will continue to decrease. The beginning amount does not change. We started with that, that's what we always have. And this constant will not change. So what we have to do is first figure out what that constant is, so we can have an equation to find the amount at any given point in time. So we know currently our equation is going to be 800, what we started with, e some constant times t. So our goal right now, we have to figure out what that constant is. So we have an equation we can use. To do that, we are going to use the fact that we know in 2.5 years we only have 400. So the amount at that given time was 400. My beginning amount was 800. E, we didn't know our constant, that's what we're trying to find. But the time at that given point was 2.5. So we're plugging in the variables we know so we can find our constant. So if I were trying to solve this equation, what would you do with your 800? Divide. Okay, so 400 divided by 800 is 1/2. E, k times 2.5, I'm just going to write that as 2.5k. How did we solve equations like this? Yeah. Since it's an E, I'm going to write a natural log. What happens when you have a natural log of E?
Choose one.
natural log of v is 1, so that goes away, so I can divide by 2.5. And this is not my final answer, but it's telling me what my constant is. So on my calculator, I'm going to do the natural log of 1/2 divided by 2.5. And when I do that, I get a constant of negative 0.2773. So
Those are for K.
that is the K value, and that doesn't change. So now I have an equation. So if I could give you any time, and you could tell me how much is left. I could say 1 year, 7 years, 3 years. And all you have to do is plug those in for your t. So the question was, how much was present after 4 years? So we put a 4 in for t. And we're just doing that in our calculator.
You put the 4 in parentheses?
You don't have to, you could just do times.
Okay, you put
263.85.
Okay, just making sure.
Whoa.
Rate 6.
Oh, wait, you don't have to. No, no. What do you do? I was thinking you had to divide before you do the,
Oh.
where they.
Yeah, since we.
It's a different one.
Alright, so this was kind of a two-step problem. First, we had to figure out the constant so that we had an equation we could use. Then we actually had to calculate it. It will vary a little bit depending on how many decimal places you go to. If you took your K to 3 decimal places, you would have gotten like 264 per point something. So just make sure you're showing your work so I know where your numbers are coming from, okay?
Yeah, that's what it was.
Alright, we're gonna try another one like that. So, if 600 grams of a radioactive substance are present initially, so this 600 is my A sub 0, my beginning amount. And 3 years later, only 300 grams remain. How much will be present after 6 years? So my goal, the amount, is A sub 0, which is 600, E to the KT. And I have to first figure out what K is. To do that, I'm going to use the other information given. In 3 years, we had 300 grams left. So what is my A of T?
A3 equals 300.
A of 3 equals 300. So we can say 300 equals 600 e to the k times 3 power. So divide by the 600. And then
Or a natural.
we know the natural log of e is just 1, so that goes away. So divide by 3. So we have a natural log of 1/2 divided by 3. We need to go to 3 to 4 decimal places for your k. You will have a slightly different answer depending on how many. This is negative 0.2310, so just negative 0.231. So now I know what my equation is. It's 600 e to the negative 0.231 t power. That's my equation I use. So our goal was to find how much we had after 6 years. So you just plug in a 6 for your time.
150.04 grams.
Really count.
one was measured in grams. So is this exponential growth or decay?
Decay.
Decay. We have less as time goes on. All right. Questions there? Oh yeah, it is. All right. Another situation where we can use this stuff is with interest. So we have talked about interest before. If you look on the front in those 4 boxes on your handout where I gave you formulas, I put the interest formulas that we've used before. Remember, the first one is regular compound interest. The second one is continuous compounding. So it says, how long will it take for the money in an account that is compounded continuously at 5.75% to double? So when I say continuously, what formula are you using?
365.
I'm asking for how long. I don't know my time. The 5.75% is my rate, but remember, how do we use it?
0.0575.
Okay. And I didn't give you a lot of information. I just said I want it to double. So I didn't really tell you how much you started with. Pick an amount then. What do you want to start with? 1,000. If it doubles, then how much do you end with? So now let's plug into our formula. A is 2,000. P is 1,000. E to the R, 0.0575.
Oh, so then it's the exact same thing.
So how do we solve this? Natural log on each side. And we use the natural log because the natural log of E is just 1, so that goes away. So then we divide.
That's a kind of a large number.
So we get 12.0547, and time is in years, so it's taking just over 12 years to double the amount of money we had.
So for things like
Wait,
this,
that's
you
a
can
final
just plug
answer?
in answers.
Yeah, if I just said double, you can just pick whatever you wanted. If I had said triple, then 3 times it. Yep. All right. So far, so good? No, you could do 1 and 2 if you wanted.
Hey.
Yes, sir. What?
Either 1 and 2.
Compounded.
How long will it take $1,000 invested at 2% interest, compounded quarterly, to grow to $2,700? So what formula am I using?
A equals 1 plus.
Yeah.
What is the 1,000? That's my starting amount, my P. My rate,
Oh, rate is 0.02.
my N,
No,
Quarterly 4.
my time,
You don't know.
that's what we're looking for, my A,
Wait.
2,700.
okay. That's good.
Do we have to put that all out?
no. Just at least show me how you're plugging things into your formula. So at least write this line for me. So then what do we do?
Wait, is it 50?
Divide by 1,000.
And you get?
2.7.
All right, let's go ahead and do 1 plus 0.02 divided by 4. That's 1.005 to the 4t power. Now what? And you could do natural log, but there's no real benefit here because we don't have it.
Wouldn't the 4T go up front?
Mm-hmm. And then, isn't this like the problem we've been solving?
Divide by log 1.005.
I'm going to divide by my 4 at the same time, but you could do it in 2 separate steps. When you put this in your calculator, either do the fraction form or make sure you put a second set around the entire denominator.
Oh. No,
Yeah, 49.
Yeah, I see what I did. Put log 27.
Oh, that would do it.
There it is.
What's that at the end?
Years.
I remember doing change of base, but I don't remember how to do it. I just remember the name. I assume it's something
All right.
like changing of base.
Is this okay? Last thing I want to talk about is the change of base formula. Now, I know you guys think you know more than I do. I know you can go in the calculator and put in log of whatever base you want. Okay? You can. But
Takes a while, but yes, you can.
you have log and natural log buttons. On a test or a quiz, I would say use the change of base formula. And that means if all you do is write down the final answer, I am going to assume you didn't use the change of base formula, you just did the shortcut on your calculator, and I will not give you credit for it. Okay? So, I want you to show me the work on it. So there is a formula that we can use, but really if we think about it, I'm going to give you a justification for why this is, okay? If I said log base 2 of 9, do we know 2 to what power equals 9? No. The 2 buttons we have easily accessible on our calculator are ln and log base 10, okay? So we can't just plug this in our calculator. If you had set this as an exponential, if we said equals x, then you would say that means 2 to the x power equals 9. Can you get a common base here?
No.
So then what do?
Change base.
You add your logs. So this is why the formula works. Then what happens with your x? So you get log 9 divided by log 2. So when we're doing the change of base, we could change to whatever base we want. We're going to go to log 10, base 10, or the natural log, because they're on our calculator. And it's just the log of the argument divided by the log of the current base. So you can remember the formula. You could set it as an exponential and solve it just like we've done all of our other problems. Right? So let me show you the minimum of what you would have to show me on one of these problems in order to get credit. If I ask you to approximate this to 4 decimal places, I want you to use the change of base. So you have to write the line with the change of base formula. So you could set it equal to x and do the whole process, or you could just say, okay, I remember that's log of the argument divided by log of the base. That's all the work you have to show, then you go to your calculator. Log 7 divided by log 5. We get 1.2091. It's not so bad. So B, how would I set this one up? Log of the big number divided by log of the small number. And we get? This stuff okay?
Alright, go home for the day. Enjoy your weekend.
So there is a math Excel assignment,
Oh.
but it's not too terribly long, so I think.
We're gonna be flying through the sky, we're gonna be doing our next, so we're flying through the air.
Yeah, we're gonna go